So in this video, we're going to look at volume, and in particular, volume of cubes and cuboids, okay? So the first shape I have here is a cube, of course. You've got a 3D box-like shape. It's a cube because all of the sides are equal. So our formula for cubes and cuboids, it's the same, and it is, again, similar to the area of a square and rectangle. It is not in your log tables. The volume of cubes and cuboids also is a formula not in your log tables, so it's one you need to learn off by heart. The volume is the length by the width by the height, okay? And just like with the shapes we dealt with in our area video, the first thing you're going to do when you identify the shape is write out the formula in full. So V equals L times W times H, length by width by height. Of course, we're dealing with a 3D shape, so you've got to watch out for your units here as well. If we're dealing in centimeters, then the volume is going to be centimeters cubed. Okay, so let's use our formula. So we've identified we've got a cube, we want the volume, we've got our formula written out in full, and now we're going to fill it in. Obviously, we don't know what the V is. That's what we're looking for, the volume. The length of this cube is, of course, 8. And since we know it's a cube, that means the width has got to be the very same, and so does the height have to be the very same. Oops, 8. So on my calculator, I will do 8 times 8 times 8, and the answer is 512. Don't forget your units, centimeters cubed. Okay, so now let's have a look at this cuboid. All right, so again, the minute you identify that it is a cuboid, get down the formula in full. We're looking for the volume here, so keep V as V. The length is 14, the width is 5, and the height is 2. Okay, now it doesn't really matter what way around you put these, because with multiplication, order doesn't matter, as long as you multiply your 14 by your 5 by your 2, and you will get 140. Don't forget centimeters cubed, because of course it is a 3D shape. All right, so if I then scroll down here, now, what if you are missing some length? So take a look at this question here, where I'm given the volume, but I'm looking for the height. So again, immediately when I identify the shape, we're talking about a cuboid, we're talking about volume. This is the formula, get it written out in full. And this time, of course, I can fill in for the volume. The volume is 648. The length is 18 of the cuboid. The width is 9. And the height I don't know, so I may just leave that as H. Okay, so now what I can do is I can multiply my 18 times 9. So I get 648 equals 162 times the height. And then, remember from your simple equations video, if you are looking to get H on its own, which of course that's what we want to figure out what the height is, then in order to get rid of times 162, I will divide by 162. That will get rid of that and give me the H on its own, which is exactly what I'm looking for here. But of course, if I divide that side by 162, I've got to divide that side by 162 as well. And when I do 648 divided by 162, I get 4. Don't forget your units. We're of course dealing with 4 centimeters in length, as we have in the question. So the height is 4 centimeters. Okay, so now we have a cube, and again we are missing the length of one of the sides. We are given the volume. The volume is 343 centimeters cubed. So again, the minute we identify the shape and we know we're talking about volume, get the formula written down for yourself in full. So make sure you have V equals L times W times height, and now fill in what you know. Well, we know what the V is this time. The V, the volume in other words, is 343, so fill that in. The length is, well, we have just X down for the length, so we'll put that in there, X. The width then, well, since we know with a cube, the length, the width, and the height are all the same, then I'm going to have to put that in as x, and of course the height in as x as well. So what I have now is 343 is equal to x times x times x, and that is of course x cubed. Now, the only way to get from x cubed to x on its own is to undo the cube, and the way you undo the cube is to cube root 343. Okay, now I'll do that on my calculator. So what I need to do is I need to look up here above the square root sign. I'll see there's a little cubed root symbol, so I'll press shift and that will come up. Do you see with the little 3 on it? And then I'll put in 343 and the answer I get is 7. So the x is equal to 7. And don't forget, centimeters is the units. Okay, so watch out for this. In order to undo a cube, you cubed root. Okay, and your calculator will do that for you. In other words, you're trying to figure out what number times by itself 3 times 7 times 7 times 7 will give you 343. So undo the cube by cubed rooting and you will get your answer. So taking a look at some irregular shapes involving cuboids, let's take a look at this example here. So if you remember from our area video how we tackled irregular shapes there, was we split the shape up into 2 shapes that we knew how to get, in that case, the area of. In this case, what we'll do is, and you can see they've already given us a little hint here, we're going to split up the shape into 2 shapes that we know how to get the volume of. Okay, so we have to get the volume of the whole thing. Okay, so what I'm going to do is I'm going to split it up as they have done there, okay, along that line. I'll call this top shape A and this bottom shape B, okay? So the first thing we need to do with shape A is identify what kind of shape we're dealing with, and the top shape is a cuboid. So the volume of a cuboid is length times width times height. So get that written out for yourself nice and clearly. Okay, so let's do that. So the volume, we don't know. Now, just be careful here. What can be tricky with the irregular shapes is identifying the correct dimensions for the part that we're looking at. So first of all, I'm going to look at the length, and the length I will take as this bit here, okay? And that's given to me nice and clearly there, and that is 6. The width, however, of the shape is this length here. Now, they haven't given that to me, but they have given me enough information. They always have to give you enough information. They have given me enough information to figure this out, because that width there is going to be the same as that width there, is going to be the same as that width there, which is going to be the same as that width there, okay? So they are all the same, and in which case it must be 9. The height of that top box is given to us clearly, and that is 5. So there we go, 6 times 9 times 5. And 6 times 9 times 5 is 270. And don't forget your units, centimeters cubed. Okay, now we're going to look at the bottom box, shape B. And again, it's a cuboid, so V equals L times W times height. Length times width times height, in other words. So again, we don't know the volume, so keep V as V. The length, now the length quite clearly is 14. The width is the same as the top, so 9. And the height of this one is also, okay, 5. You can see that there. So 14 times 9 times 5 works out to be 630 centimeters cubed. And so for the total, we will add 270, add 630, which is 900 centimeters cubed. Okay, something else that you can be asked about with cuboids is surface area. All right, now with surface area, it is exactly as it implies there. What we need to do is get the area of every surface, okay? Now the surface, what we mean by that basically are the sides, the top side, the bottom side, the front, the back, and the left hand side and the right hand side, okay? So we don't have a formula for this as well in our log tables, okay? And although some people like to use a formula, there's no point, I think, in trying to create something else that we have to remember or learn off by heart. We have enough things that we have to memorize. With surface area, I think it just makes, it's quite clear what we have to do. We've got to get the area of every surface. So what I like to do is I like to write it out nice and clearly for myself, bit by bit. What we're going to have to get is, let's say we're going to have to get the front, the area of that front surface, okay? I'm going to do this bit by bit. We can see quite clearly front, back, top, bottom, left hand side, right hand side. There are 6 surfaces altogether. But of course, the front side is going to be the very same as the back, and the top is going to be the very same as the bottom, and the left hand side on a cuboid is going to be the very same surface as the right hand side. So we don't have to do 6 calculations here. We can speed it up by actually only focusing on 3. Let's have a look at it bit by bit, and then you can obviously speed up your calculations the more you get confident with these types of questions. Looking at the front surface, all right, now just the surface, and this, for the surface we're only ever looking at the flat shape. So the surface there and the front shape is a rectangle. So what's the area of a rectangle? Well, the area of a rectangle, of course, is length times width, okay? So let's see, what is the length of that rectangle and the width of that rectangle, okay, if you're just looking at that flat surface? Well, that length there must be the same as that length there, okay? And that length there is going to be the same as that length there. So although we can't clearly see what the length of that rectangle is, we do have enough information in the question to figure it out, okay? All those 3 lengths have to be the same. So the length is 5 and the width must be the same as that width there. So they are the same. So that is 2. So the answer is 5 times 2, which is 10 centimeters squared. Now we are talking about area, in which case we're talking about the flat 2D surface. So it's centimeters squared is the units. Okay, so that's the front. The back, well, the back is going to be the very same. All right, the very, very same. That front and back shape or surface is going to be the very same. So now let's have a look at the right hand side. The right hand side shape is, of course, a rectangle again, and it is length 14 and width 2. So 14 times 2, which is 28 centimeters squared. All right, so in this case, the right hand side has a surface area of 28 centimeters squared. The left hand side is going to be the very same, 28 centimeters squared. Okay, lastly, we're going to look at the top. And again, the top is rectangle, so length times width. And the length of that top rectangle, there's the top rectangle there. And the length of that top rectangle is, of course, the same as that length there, so 14. And the width of that top rectangle is clearly 5. Now, just be careful. With these, again, it's a little bit like the irregular shapes. The hardest thing about it is getting your correct dimensions. So always do a double check and be very careful. So 14 times 5 is 70 centimeters squared. That's the top. And of course, the base or the bottom is going to be the very same, 70 centimeters squared. And now once you have all your surfaces, what we're going to do now is we're going to add them all together. Okay, and that will give us our total surface area. So the final answer when you add them all together is 216 centimeters squared. Okay, So let's get the surface area of this cube. Well, in this case, we'll do a similar thing. We will get all 6 sides. We're going to deal with the front, the back, the right hand side, the left hand side, the top, and of course the base. Well, let's have a look at the front. Now we'll call this bit the front, shall we? So this surface here is a square. Area of square, of course, is length times width. So in this case, we have 8 times, the width is the very same in a cube. We have a square shape, of course, it's a square surface. So 8 times 8 is 64 centimeters squared. The back, of course, is going to be the very same, 64. The left-hand side we'll do next, shall we? The left-hand side is going to be, again, although it's not given clearly here, because it's a cube, all of these sides and dimensions are 8. So that's going to be 8 times 8 as well. It is, of course, a square. So 8 times 8 is 64 centimeters squared. And of course, the right-hand side is going to be the very same. So it's going to be 64 centimeters squared also. And then, of course, looking at the top, it is a square again. So length times width, 8 times 8, which is 64 centimeters squared. And the base is going to be the same. And what we're going to do now is we're going to add them all together. So the answer is 384 centimeters squared. Now you don't have to do the full layout like this. If you've spotted straight away, look, one surface is 64, the 6 of those surfaces are going to be the same. You could quite clearly do 64 times 6 and get 384 centimeters squared. The reason I like to explain it out in this format is because what you will see when you go on to the video about prisms, when these shapes get a little less straightforward, cuboids are the most straightforward type of 3D shape that you can deal with and get the surface area of. But you could be asked to get the surface area of more complicated prisms. And in which case, it really is good to just keep laying it out for yourself. Okay, I'm going to look at the front first, then the back, then the left-hand side, then the right-hand side. And doing it bit by bit allows you to ensure that you are getting every single surface and that you're mindful of what shape every single surface is. So it is a good way to introduce surface area. But by all means, if you can speed up how you're doing it because you totally understand what you're doing, then do that. But as we move on to the prisms, you'll see that this layout will prove to be very useful to you there as well.